Alright. Chapter 4, multiple choice. Number 3. Alright. Tension equals sine 30. T over sine of 30 equals 100 mg. So T equals 100 over sine of 30, which is 200, since sine of 30 is 0.5. So 100 times 2, 200 newtons, 6. So angular momentum equals moment of inertia times angular velocity. So the angular momentum equals 4 times 1, which is d4. 7. K, kinetic energy, equals half of moment of inertia times angular velocity squared. So K equals half of 2 times 1. So K, the kinetic energy, equals 2 joules. 6, 7, 10. Alright, 10. So you rotate the force exerted on the bar O, where it is pivoted, is best represented by what vector, whose direction is which of the following? So you pivot the stress, the tension, over the y-axis, giving you B, which is the answer. Alright, 13, I believe. Alright, so I, moment of inertia, equals I naught, which is the center of mass, moment of inertia on the center of mass, plus md squared. D equals L over 2 squared. So I equals I naught plus ml squared. The L was squared, and then 2 squared times 1 over 4. So it's a I naught, the moment of inertia, equals I about the center of the mass plus 1/4 ml squared. 13, 14. All right. So the mass. So m times L over 2 plus m times L over 2. The full length of the thing over 3m. The total sides, the total amount of sides, gives you ml over 3m. So the m's cancel, L over 3. B is about a third of the way up. Alright, so 15. So the torque equals moment of inertia times alpha, the angular acceleration. So the angular acceleration, so moment of inertia equals 3 ml squared plus m 4l squared. So that gives you, it comes out as 7ml squared alpha. So T equals L3 mg minus 2 LMG, and then that equals 7 ml squared alpha. So the L's cancel, the M's will cancel, or at least one of the L over here, leaving you with 7L alpha, and then 3G and minus 2G, so 1G, and then divided by 7L. 7L equals the angular acceleration. So let's see, what was that, 16 now? Yeah, 16. All right. I don't know. Couldn't figure 16 out. 18. We knew 18, yeah. So 2m, the 2m's over 2l. 2m over 2l will equal m over l, which is a 1-to-1 ratio, so B. All right, 19. So you know that the angular momentum, or linear momentum, equals mvr, and v is the same as omega. So m equals omega, or m times omega R equals the linear momentum. Alright. 1922. Alright, 22. So, the horizontal velocity of the ball thrown most nearly is, so we find the t to, using the y value, so delta y, 45, equals 4.9 times t squared. T equals 3.03 seconds. So delta x equals v naught x times t, so 30. You got all the numbers. So 45 horizontal, 30 apart. So v naught of x equals 9.910. Alright. Alright. 23. Yeah. Yeah, nope. 25. Alright, yeah. So, for the ball to move horizontally and then move up vertically at these directions, the force would have to be this direction. So, if it were exerted this direction, the ball would go too far to the right. This direction, just go straight up. The ball would go more at an angle, and then at this direction, it just most nearly go at that direction. So B is the only way for the ball to go vertically up. Alright, 26, 28 is the next one. Alright, so so GH cosine is this line, this point, equals half of mv squared. So to get to this point, we have to figure out the velocity. So the mgh equals the kinetic energy, since this is the lowest point, max point, set them equal to each other. So gh times 0.5, cosine of 60, 0.5 equals half of v squared. The m's canceled. At some point there's supposed to be an m there, it's fine. H equals the L. I just have mgh. So R equal, or V, so V equals radical GL. Alright. Let's see. 31. Alright, so force equals work over delta x. So force, the work is 4 watts over the 2 meters per second, 2 meters at that 1 point second. So force equals 2N. 31 is E. 32 up here. So a student initially stands on a circular platform. The student jumps off. Which of the following are conserved, or yeah, the forms that are conserved. So angular momentum, unless that child is spinning, it can't have angular momentum. So that angular momentum is only within the circular platform, merry-go-round, whatever it is. Linear momentum, so the kid jumps off having momentum, but it sends so the kid jumps off that way, it will send the circular disc in the opposite direction, giving them both momentum. And then kinetic energy, again, same concept. He jumps that way, the sphere or whatever will go this way, and they both have kinetic energy in opposite directions. So A, angular momentum is the only thing that's conserved within the disc that he is, the platform that he's on. 33. Alright. Which of the following graphs represents the angular acceleration? So first off, it'll start off very slow, and then once it hits this point here, it'll hit the maximum velocity and then slow down exponentially. So it'll increase slowly, but very quickly at the same time, and then it'll die off, and then it'll come back down. So D is the answer. And 35. So my first answer, I put E, which is incorrect because this would be here. It'd be a straight line. So D, the distance is slowly increasing because the velocity is increasing. stays constant, well, the velocity is constant, and then it'll start to die off. It'll start to remain at a constant distance until it'll stop as it decreases. Alright, is that it? Yeah, I think that's it.